even and odd functions. So our objective for this video lecture, we have two. We want to determine whether a function is even or odd from the graph, and we want to determine whether a function is even or odd algebraically. Okay, so graphically, pretty straightforward. All right, and we'll just kind of take a look at this quickly. Graphically, a function is even if and only if its graph is symmetric with respect to the y-axis. So if you draw a line, if you hold a line on the y-axis, if the right side, you fold it, if the right side matches to the left, it is an even function. So here's an example of one that's even. An odd function, a function is odd if and only if its graph is symmetric with respect to the origin. Okay, if you recall, symmetric with respect to the origin means it can be rotated about the origin less than 360 degrees, and you can come up with the same graph. If you look at this graph, if you rotate this 180 degrees, you'll have the same graph. So this is an odd function. Okay, so again, even, symmetric with respect to the y-axis, odd, symmetric with respect to the origin. Okay, let's take a look at algebraically. All right, algebraically. Algebraically, a function is even if for every x in the domain, the number, the opposite of x, or negative x, is also in the domain, and if you put the negative x in as the argument or the input, you'll get the same y value or the same f of x. Let's go back to your graph and you can see that. Okay, if x goes in, x gives you a value here. Let's put x here. That's the value, f of x. If x is here, then the opposite of x is over here. It's in the domain, and f of x is also the same, the opposite of x also has the same f of x value, the same y value. Okay, a function is odd if, again, for every number x in the domain, the number negative x or the opposite of x is also in the domain. And in this case, when you put the opposite of x into the function, you get the opposite of the function's value. Okay? So let's go back to the graph. As you'll see here, if x goes in this case, let's say you put in this value of x, out comes a positive y. When I put in the opposite, out comes the negative of the y, or the f of x. Okay, that's an odd function algebraically. Let's do some examples, and we'll even pull the calculator in, and we'll make sure we see what's going on. Okay, we want to determine whether or not these three functions, we'll do three of them, are even or odd, and we'll first do them with a graphing utility, and then we'll take a look at them algebraically. So example 1, f of x equals x squared minus 5. Let's take a look graphically. Okay, I think we can see that. Okay, let's see here. Y equals x squared minus 5. I'm gonna do my zoom. I'm not sure where my calculator is, so I'm gonna press zoom 6 to make sure I'm on the standard screen. And there is my graph of x squared minus 5. It looks pretty clearly to me like this is an even function, given that it appears to be symmetric with respect to the y-axis. Okay, let's see how that looks algebraically. Algebraically, we want to replace x with negative. Oops, let me come down a little bit here. We want to replace the x with a negative x and see if we get back the original function. Okay, if we get this back. So let's see here. Okay, let's put negative x in. Okay. And if we put negative x in, we get negative x squared minus 5. And we know that the opposite of x squared is x squared. So we get x squared minus 5. And right here it tells us x squared minus 5 is equal to f of x. So when the f of negative x is equal to f of x, we have an even function. Okay? So we can see right here algebraically it's even. Okay, let's look at another example. Oh, let's see. I'm gonna put a little bit closer to save a bit more space. It looks like I just let's get it wrapped up here. Example 2. Okay, so my example 2 is, we'll call this function the g function, and its rule is x cubed minus 1. Okay? Well, let's see. Let's take a look first at the graph of this and see what we can come up with, what we can determine, if anything. Y equals, all right, I want x cubed. So x, let's first clear that. X to the third power minus 1. Okay, I'm going to graph that. All right. Well, it's certainly not even, because the y-axis is not symmetrical with respect to the y-axis. And if I were to rotate it, this is going to be up here. This little kind of flattish section after 180 degrees is going to wind up here. So it is not symmetric with respect to the origin. In order to be, well, I didn't say that. It is not symmetric with respect to the origin. So neither of these should work. Let's take a look algebraically. Let's first look at our even, if it's even. Okay, so let's start off, let's put negative x in there. Excuse me, I want to use g. So I want to put negative x in to the function and see if I get the same thing out. Okay, so negative x cubed, negative x in parentheses, cubed minus 1. Well, negative x cubed is negative x times negative x times negative x, and that's equal to negative x cubed minus 1. And as you can see, these two things are not the same. This is not equal to the original g of x. So this is not even. Okay, let's check out odd. Okay, odd says if I put the negative x in, I should get the opposite of the function. Okay, so I'm going to again put negative x in. Okay, let's see here. I'm going to do negative x cubed minus 1. Whoops. This is equal to, as I have here, negative x cubed minus 1. And this is not equal to the opposite of this. The opposite of the function, the opposite of this is negative x cubed plus 1. The opposite of this entire thing, the negative 1 distributes to both. Well, negative x cubed minus 1 is not equal to negative x cubed plus 1, so it is not odd. Okay, let's do an example 3. I think I'm still on the screen there for you. Okay, my third example, let's take a look at h of x, so we're okay with different names for functions, is equal to 5x cubed minus x. Okay, well, let's see here. Let's first use our calculator and see what that looks like. Turn it on, go to my graph, press clear. 5x cubed minus x. Okay, graph. Oh, that looks like it's certainly not even, but it looks like, let's see, I could even, maybe let's zoom in just a touch. Let's make my window, let's go from -5 to 5 and look a little bit closer at the origin there to see what's going on. Here's what's coming at the origin. Oh yeah, again, it's certainly not even, it's not symmetric with respect to the y-axis, but if I rotate that from 180 degrees, so this goes around to here, it matches right back up again. So it is an odd function. It is symmetric with respect to the origin. Okay, what does that mean? Okay, that means if I put, I'll do that a little bit differently this time. Let's take a look. Okay, let's track it. What we know here is if h of x is this, the opposite of h of x is the opposite of 5x cubed minus x, which equals, whoops, I forgot the negative. Okay, equals negative 5x cubed plus x. So I'm choosing in this example, remember the goal for an odd function is we want to put the negative in and we want to come out with the opposite of the function. So I'm choosing in example 3 to say, well, what is the opposite of this function? Well, the opposite of this function, the opposite of this whole thing, is right here, negative 5x cubed minus 1. That's my, oh, whoops, plus x. Excuse me, I bet you caught that. The opposite of negative x plus x, excuse me. That's the opposite, so that's my goal. So let's test it. Okay, odd. If I put in a negative x, I want to get to here. Okay, so 5 times negative x cubed minus parenthesis negative x. Everywhere you see an x, the argument, put in parentheses and then put what is inside here in those parentheses. Well, this is negative x times negative x times negative x. That's negative x cubed times 5. That's negative 5x cubed. And of course, the minus the opposite is plus x. Ah, I got that. So indeed, it is odd in this case. Okay, so again, even and odd. Even, it is symmetric with respect to the y-axis. And if you put the opposite of x into the function, you get the same function back. Odd, it's symmetric with respect to the origin. And if you put the opposite of x in, you get the opposite of the function back.